Now, something I was thinking about is that the last set of parts I was doing had multiple angles on multiple depths of the part, different locations on the part. I had three different steps, and each step involved four angles. So the unit was not, it just didn't seem right. So I had to go back and put in the manual one. That's why I went ahead and changed the steps per motor back to 5. But anyway, that brings you to another thought, is that, when you're rotating the part, how do you actually know the location, even though the display says it's rotating, and that's part of the problem. It's incremental. So you don't want to lose your position, and I don't think it's a problem of misstepping, but sometimes when you push the button, if you push it too slow, it'll go 2 steps, and if you push it too fast, it'll skip a step. I mean, it's not a perfect thing, but I mean, it's, you try to make it as good as you can. So there's got to be a way of actually putting something on here to make it, well, to read what position you are, where you are. And I saw several things online that were a lot of the controllers, they control the motor, but they don't actually read it. So what I'm trying to do is I'm trying to read the position of the indexer. I'm not actually trying to control it. And some of the stuff involved these calipers where, you could take this cover off the top and put wires in there, and you can read it on a display. And that's good for linear motion, but I want rotary motion. So then the thought is that, can I convert something into a rotary motion instead of a linear motion? So I was looking at these calipers, and obviously when you're in the inch mode, it's not reading any kind of rotational value. And when you go into the fraction mode, that's even worse. But when you get into the millimeter mode, you notice that it'll go like 1, 2, 3, so on and so forth. And if you look at this closely, if you don't read it as millimeters, but you could read it as degrees, like this is 19, almost 20 degrees. This would be like machine degrees, where they're not broken up into minutes and seconds. They're broken up into, this part here is 0 to 100, which reads the degree. So like this would be almost 21 degrees, 0.2. And then if you get it to 2150, that would be like 21.5 degrees, and then you go up to 22 degrees, and so on and so forth. Now that's reasonable. We could do something with that. So then the thing is, how do you convert linear motion into rotary motion? So there's a couple of things I thought of, that if you had attach a cam to the front of your machine, to the front of the index or the back of the index, or wherever you want to attach it, and you had basically a slope. Now the slope would, just think of it as a thread, but you had it to where 360 degrees is one full revolution. So that, let's say the end of this piece, as it's moving, it's riding up and down, riding up that angle, and it's changing this. So as you go up, it's changing it. And if you was to make this one revolution, which is equal to, that would be 360, thereabouts, and convert that into inch. So if the point of this and the end of it was 1 inch 418, or 1 inch 400 actually, somewhere around there, that would be 0 360. So I was thinking about that. Now another way you could do that is, instead of having something attached to the center line, you could have a cam attached to it, and this being the center line, this being the cam, and looking at the cam from a side view, it would look something like this. As this spiral went out, when it got to this point, this would be your whatever I just said it was. Somewhere around there. This would be your 1 inch 400. So as this went around, if you had like a dial indicator, or even if you had, this mounted so that this would move, as this cam went around, it would give you a reading. As this cam went around, it would give you a reading. Now, the thing about these calipers is that you can go up to the, it'll work both ways. If I go 360, and I was to zero that out, now this would be 1 degree, 2 degrees, 3 degrees, 4 degrees, so on and so forth. So then when you get all the way to the bottom, you reach your 360 degrees. But that was a thought I had about attaching this head to the side of the machine and having something out here, maybe with a wheel, so it would follow a cam. Now if you go, I know they have readers. They mount to the machine. A lot of people use them on the Z-axis, and they're basically a caliper mounted, and then this is attached So as you're moving, it moves like that and you get your reading. But I really didn't want something on the machine because then you'd have to kind of squint to look at it. And I wanted in a where I had my my indexer switch / brake. I wanted to mount basically a screen onto that so that I'm not near the unit, I'm right by the switch all the time, and I could read what the numbers were. Now they have these I don't know what you call them, they're remote, but it's basically the bar with a reader on it, but the screen is not on the bar. There's a wire and it's got a remote box. So you can mount the reader like on a y-axis or x-axis and have the box mounted somewhere else so you could read it without having to look at the caliper itself. Now I thought that was a pretty good idea. I can mount that. But then the issue again is to come up with a cam type design that would be very fluid to move back and forth. And you don't really want to have to put a lot of spring pressure on it to keep constant pressure on the wheel. You had a rotating wheel or a bearing of some sort. But that was something I was looking into because I got to have a way of knowing that when this thing rotates, it's actually rotating the correct angle. And I mean, you know, some parts, you know, like if you're making gears or whatever, you know, you get to the end, you'll know, unfortunately, whether or not it's correct. But when you're dealing with other parts, you have to have a little more confidence. So I made this little wheel thing, and I'll show it to you. Now I'm still looking at this idea. I really like this idea. I just got to get it to work. And I got to look into that, but I got to have something. I won't say now, but you know, I want something immediate because this is kind of like it's going to be a, you know, not, I won't say a long-term project, but it's not something I could readily do quickly. It's going to take a little bit of engineering and a little bit of trial and error, and the cam action isn't really what I'm looking for in the end. The end result of what I'm looking for is a encoder where I can mount it on the machine and it reads it and it puts it on the display. And I was looking at you know, Arduino, and they have some encoders out there that are, you know, you got to hook them to a computer and this and that, and I really don't want to have to put a laptop or something out there. You know, I want to make it, you know, quick and accurate. And but I need something now because I got a lot of stuff to do, and it's got to be accurate. So let me I mean, I'm going to work on this, but I got this set up over here. You can't see it yet, but you know, eventually this is the end result, something over here. But temporarily we got this over here, so let me show you this. So what I did here was that this wheel, this piece of I-beam I cut, And I haven't finished it. This has got to be cut and trimmed, and got to put some holes in here. But I want to mount it to the indexer like this. And what it's going to do is this black plate on the back. I don't know if you can see it very well, but this black plate is the original plate that was on the back here. And like I said before, that this aluminum plate is one that we had that we were going to use for a job, and it didn't work out for the job because they went a different route on the job, and we already made the plate, and that's why these holes are in there for indexing it. But so I got the plate, I borrowed it, got that, borrowed it, and I've been using that. And this other one, like I said, is the original one that was on the machine. So what I did was I mounted it on here. And I'll take it apart and show it to you, but I want to show you what I'm trying to do here. So this aluminum piece, the disc, which, like I said, originally was this disc on the back, which is aluminum, I cut a groove in it. And what I was trying to do is, I'm using this plate as a index to check the rotation of this indexer. Now as I rotate this, you see it go to the different degrees. We start off at 0, 10, 20, 30, 40, 50, so on and so forth. So what I did was I took this aluminum plate, and what I'm basically doing is rotating this plate against this plate. It's like the old Toro lawnmower. It's got a round circular plate on the bottom, and then there's a wheel that rides on it, and as you move the wheel in and out, it changes the speed of the mower. So if you was to have this plate further back or further forward, it would change the speed of this. So you have to be able to match. These both have to be the same identical diameter. The outside of the rubber band has to be in the same location as the outside of this part. So I had to make the disc smaller, because if I use this rubber band on it, the diameter would be too big. So I had to cut down this. And what I did was I wanted this to ride against this to give me a rotation. And this aluminum piece, I had to put something on here so that it wouldn't slip. Originally I thought, well, maybe I'll just glue some rubber piece on the back of the original one, and it'll ride on this aluminum plate. But then I thought, well, I'll just put an O-ring in here, and that would work really good. And you know, you can get those O-rings where you splice them and you make your own. It's an O-ring kit basically. So I thought, well, you know, that's then I'd have to cut a really deep groove in there and this and that, and well, I'll just put a rubber band on there. You know, it's nice and, like, I won't say sticky, but you know, it's not slippery, so it gives a lot of friction. So when I rotate this part, this other piece will rotate. And I thought, well, that's pretty good, you know. So I had to cut it down a little bit. And this is mostly, you know, to check the rotation. It's not a permanent thing. It's one of those temporary things. I hope it doesn't turn into one of those temporary permanent things. But while I'm working on this idea, I can put this up there, and that'll get me up and running. So like I said, I put a groove inside of this aluminum piece so it captures the rubber band to keep it from falling off. And I think there's a 7 or 8 thousandths difference between the outside of the aluminum and the outside of the rubber piece, so that it'll ride on the rubber piece and won't ride on the aluminum piece. So of course, you know, you got to make sure that's right. So I got this degree wheel that I used. I had it from the old motor days, you know. I don't know if you can see that. I don't want to swing the unit around either, but it's basically a protractor. You know, it's a 0 to 360. This was for setting the timing on the engine. I had it laying around. So I got a little pointer there. I don't know if you can see that. Put you in a little closer. See the pointer there? It's not set to 0 right now, but I'm going to rotate this and find out where I am. Okay, I'm at 0 there. And here I'm at 0. Hang on a second. Try to put you on this box here. A little more stable. There we go. That's a little better. That's even a little more better. So what's going to happen here is when I go to index this part, or a part, it's going to rotate. That way I can read the degrees. So this like being 90, 100. Oh, my little piece of wire is hitting the thing. $300, all the way back to 0. So, like on the other part, I was going -10, then I was going 40, which would bring me to 30, and then I was going 40, which would bring me to 70. I was going 40, so on and so forth. So after I get done with that, I'll bring it back to 0. Of course, you bring it back beyond 0, and then you bring it back to get the, make sure the backlash is out of it. And I go back to 0. So I check this, and that's back at 0. So this is kind of what I was thinking about. I was going to go ahead and mount this guy. And that way, at least it'll give me a visual on where I am in relationship to the indexing of the indexer. And we go back to 360. So I can mount this on my plate, put a couple holes in there, and just mount it. Now it's a little hard for you to see this. So here I am at 180. I got 180 on the dial over here. Now this degree wheel that I'm focusing on now, it goes to 180 and then it starts back at 0. So I got 180 there. And this is back at 0 here, /360. So if I go back over here, you'll see I'm back at 0. So that's telling me that it's working. Of course, like I said, couple minutes ago, you have to have it positioned just right, because if you have it too far in, this is going to speed up. If you have it too far out, it's going to slow down. So you gotta get it just right. But once you get it right, it's really close. Now you can check the accuracy. Like if you spin it, you spin it 2, 3, 4, 5 times, and then you check the degree wheel, you'll know that if you're too far forward, too far backwards, because it'll throw it off a little bit each revolution, and then you have to adjust it. Like if you go 10 revolutions and it's off by a degree, depending on which way you are, you have to adjust it back or forth. Of course, all I'm really going to do is I'm going to go up so many degrees, go up so many degrees, and then I'm going to go back to 0. So I'm not I'm not going to be going revolution after revolution. I'm going to be going one revolution and go back to 0. But it's just a visual indicator as to where I am, and make sure that I'm not losing steps or I'm not losing count myself, or when I'm pushing the button that it's not actually moving 2 times instead of 1 time. And it's kind of like a ISO thing. You got to check this and check that, make sure it's right, make sure it's accurate. So let me put you back up here and we'll take this thing apart. And I mean, it's really simple. It's just something I threw together. And I don't know if if you're interested in making one yourself, or maybe your parts don't require a high degree of accuracy, or maybe they do. Let me move this out of the way, and I'm going to unclamp this. I got it clamped right now just on this plate. I was just sitting here playing with it. I mean, it's fairly simple. Like I said, I had a piece of channel. I laid it down. I cut this because I had to cut it here because I can't get any closer. And I had a lot of room on this side, so I left it. And I took a cut here. And like I said, I'm going to trim this off. But I wanted to leave it long so I have a stable platform so I can check it before I mount it. But I just, I mean, it didn't have to be, you don't have to follow the contour of the part, but I did. And I put that little window in there so that, I could see the number without. I could have made that bigger. I could have put a notch in there. I could have done a lot of things. So long as you have some type of pointer, so so it's pointing to the degree. It's a fairly simple thing. This is just a plate to capture the spring. This is spring loaded. Because I'm putting tension on here so when it's riding on that rubber band, it's keeping tension on it. Just a little spring-loaded thing. And there is no real bearings in it. What's happening is, see, when you put tension on here, I got 60,000 slop in here. And when you put tension on here, it actually self-centers. When you put just the right amount of tension on here, it brings that piece back. You see that back piece moving? So when you put the right amount of tension on it, it keeps it away. So there is no bearings on it. It's just a piece of Delrin I turned, fit that diameter. But this is just a little capture plate to capture the spring. I didn't need a lot of spring tension, just a little circular spring, just something I threw in there. There's all different kind of springs, and I put a little hole in there, a little counter bore to capture that spring so it wouldn't move around. Then this comes off if I get the right driver for it. Now these